Mm, Good morning. SK Goals, please start.
Okay, thank you, Hamida ma'am. Good morning to all the participants. Good morning. Today's resource person, Dr. Dheeraj Kumar, and good morning to Dr. JP Rai sir, course director of this course. Friends, I am very happy because we have successfully completed our 20 days of this workshop, and this is the last session of 21 days workshop. So for today's talk, we have Dr. Dheeraj Kumar from Pantnagar for his to introduce himself. I would like to call Dr. JP Rai sir, course director of this 21 days course. Sir, kindly give a brief introduction to our participants regarding our resource person. JP Rai sir.
Thank you. Thank you, Dr. Goyal. So, welcome all. Very good morning to all of you, including our resource person, participants, our technical team. Today's talk is on precision irrigation for efficient irrigation water management. It will be delivered by one of the eminent scholars of the country, Dr. Dheeraj Kumar. He is Associate Professor in Irrigation and Drainage Engineering at College of Technology of Agriculture and Technology, Pantnagar. Earlier it was in Uttar Pradesh, you all know. Now it is in Uttarakhand. He has completed his BTech from Chandrasekhar Azad University of Agriculture and Technology, Kanpur, as regard his academic career. He obtained his MTech degree in Irrigation and Drainage Engineering from SHIATS, now SHUATS, and formerly Allahabad Agricultural Institute, located at Prayagraj. And he completed his PhD in Irrigation and Water Management Engineering from Maharana Pratap University of Agriculture and Technology in Udaipur. He was awarded with Senior Research Fellowship (SRF) during his PhD degree program. He has been teaching irrigation and drainage engineering courses to the students of BTech, MTech, and PhD at Govind Vallabh Pant University of Agriculture and Technology, Pantnagar, since 2006. 3 students have completed MTech thesis under his supervision. He is a co-PI in PFDC project at Pantnagar Center. He has participated in various extension activities and has many research papers published to his credit. So, with this brief introduction, may I now request our resource person, Dr. Dheeraj Kumar, to please continue with his deliberation.
Dr. Thank you, sir, to give me the opportunity to deliver my lecture on this training program. My lecture is the precision irrigation for efficient irrigation water management. First of all, I will tell you what is the irrigation. Irrigation is the artificial application of water to the plant. If we say that rainfall is coming and it is also coming, it is also providing water to the plant, but we will not say that it is a irrigation. Irrigation means only artificial application of water to the plant. So then, what is the precision irrigation? What is the meaning of precision? Precision irrigation means is the accurate amount of water to the plant, and when to apply and how to apply and how much apply we will consider in the precision irrigations. In our traditional irrigation method, if you see the surface irrigation methods, further irrigation methods, check basin irrigation methods, furrow irrigation methods, there was application efficiency, we can say only 40%. But due to precision irrigations, we can get the water application efficiency up to 90%. And it is also a demand of water scarcity area in India, also just like Rajasthan, Ganganagar, Maharashtra, and Telangana. There's the water is very scarce. And with the precision irrigations, we can take the not the benefit of the water, but also for the yield also, because our land is limited, and if you want to, but my population is going to increase day by day, and if you want to complete all the amount of persons who are living in India, then we have to adopt the advanced method of irrigation, just like a precision irrigation. Precision irrigation. The irrigation efficiency of traditional method, if you see that there is only 35% or less, but in the precision irrigations, If you see the efficient use of water and crucially dependent on advanced irrigation technologies. And until the 50 years ago, crop is this country were irrigated by surface method, just like I was saying that, and in that irrigation the efficiency only 35%. But it was in the older 50 years ago, it was good. It was okay because our population is not up to 1.4 Arab, but at present, in the 50 years ago, it was the 30 crores only, or 35 crores population. And at that time, it was okay, but if we have faced the problem of the population, then we have to use this precision irrigations. This is the one type of precision irrigation. And you see that there is a drip lines and the meters is there. This is the precision irrigations. In the ancient times, the over exploitation of underground water resources has resulted in alarming fall and depth of water table well in command area. Due to the surface method application, there is a lot of water demanded, and because of 40% only we apply the water, and rest of 60% water we are just wasting and water loss. And due to this, we have excess water we are pumping from the groundwater, and this excess water they are decreasing the groundwater tables. There is an immediate need for section of the appropriate irrigation method. If you want to complete this first lines, alarming stage, if you want to stop this alarming stage, then you have to use the appropriate irrigation method, which can improve the water efficiency. And this is done only by the precision irrigation, means micro sprinkler, micro irrigation, and the sprinkler irrigations. In this lecture, in this program, today lecture, we will discuss on the micro irrigation. Micro irrigation is an important agro-technical for efficient water use and efficient management. In these micro irrigations, we provide the water and the nutrient near the plant root zone only. We are not wasting our water. We are not wasting our nutrient. We are only apply the water in the plant use. That's why we can get the high irrigation efficiency because we are only apply the water near the root zone. There is the no percolation losses. There is no weeds which can take our nutrient and water. Only amount of water we apply near the plant root zone. Look here, surface irrigation efficiency you see 30 to 45%, and sprinkler 60 to 70%, and micro irrigation methods just like a drip irrigation, micro sprinkler, bubblers, we can get the 80 to 90% of application efficiency. It means only 10% if you provide the 10-liter water to the plant, and only 1 liter water is wasting. Only 9 liter water is completely provided to the plant, which is used by the plant. And in sprinkler irrigation, this is 30% losses, and the surface irrigation is 60% losses. Means out of 10-liter water, we are wasting the 6-liter water. These are the some precision irrigation pictures, drip lines you are seeing there. What is the if you say development of it was firstly started in Germany in 1860, but in the Simcha Blast engineer, which was from the Israel, has seen the observe of a big tree near the leaking tap exhibit a more vigorous growth than the other trees. A plant where a water is leaking, so then he observed that there is a vigorous, very good growth compared to the other plant nearby that plant. He that observed by the Israel engineer in 1940. After that, initially uh, it was implemented in the farm on the field in the form of the clay pipe. We use the clay pipe, perforated pipes, and bamboo pipes. But as soon as when the plastic is developed and it is commercialized, then we have adopted to for the plastic in the field of farmers and better cost management also. In India, it is done by the National Committee on Plastic Culture Applications in Horticulture in 2001. And present, Government of India also providing the subsidy to the farmers to install the different systems in their fields. These subsidies vary from to state. Some state get the 50% subsidy, some state give the more than less than 50% of subsidy to the farmers. It depends on the location and the state and the areas. Areas means hilly areas, plain areas. According to the condition of the farmers, it depends on that. This is the ancient method of dipping system. You are seeing that this is the gravity method. A lady is pouring the water in the bucket, and this bucket is attached a lateral line, and this lateral line leading to the plants, and there a drop by drop application of water is going to there. Why is the micro irrigations? Efficient, effective water use efficiency of fertilizer you can get by this method. You can get the efficient and effective. It means only water applied near the plant root zone and no percolation losses. Only a fill capacity is maintained in the different system. Fertilizer use efficiency is higher because fertilizer is only applied by the to the plant near the plant root zone, and it was applied by the irrigation system. Uh, so in this, we provide the water soluble fertilizer, and we inject this fertilizer in the lateral lines. Hmm. Agrotechnical advantage is we see that there is no soil compaction. Compaction increase the seal the soil surface, which can reduce the aerations and which can ultimately reduce the yield of the plant. No interference with the farm practice. Farm practice, there will be no interference. You can easily operate by your farm practices and agriculture practices. Cost effective, semi effective also, and effective water also. Fertilizer, it is also an energy, labor, and the weed control also. You can see this energy, labor, and weed control. Only water and fertilizer apply in the near to root zone. There no weeds will be grow nearby the plants because you are not providing the nourishment. Nourishment, water, and nutrients. What is the advantage of dipping system or the microing system? Advantage is 40 to 60% to the way of saving of the waters. You can see in the and yield increase 20 to 50%. Reduce the labor cost. Highly uniform distribution. In this system, we can get the uniformity coefficient up to 80%, 80 to 90%. It means water is uniformity distribution to the all the plant. Only water is there will be no soil erosion or evaporation. Water there will be no runoff over the soil support. Water you apply to the plant, it infiltrate completely infiltrate to the soil. There is no if water will not flow over the surface, then there will be no erosion and no evaporation. Water is applied in optimum amount. There is also a control the disease, pest, and weed controls. Deep conclusion also water will be no water will reach the beyond the soil root zone. It means deep conclusion we can reduce surface runoff and evaporation losses also we can minimize by this methods. Poor quality water you can also do use this methods. If you have the poor quality in our area, we are also facing the poor quality water. Then in this system we can use the poor quality water with some chemical management. High return per hectare we can get by these methods. You can use the optimum crops and multiple crops in a season in a year you can get by these methods. High water use efficiency, it means 90% water use you will get. No need for the drainage systems. All water is not going to surface runoff and not going to beyond the root zone. It means there will be no required of drainage system. Fertilizer efficiency will be higher. Over irrigation is avoided. We provide the optimum amount of water using the tensiometers and other electronic device which can give the information of the real time irrigation. Real time method of how much water is going to provided to the plant. This within if it exceeds the disadvantage of different system, requires the very clean water because if you will not use the clean water, then there will be a problem of the clogging of the meters. Because we have the very small opening in the meters, and if you use the clean, you will not use the clean water. And you can take a high density leaves, and if you introduce in the waters, then it will be possible to clog your meters. So it means the small opening or path in the meter can be clogged by the soil particles, the organic matters, and mineral sediments in the water and algae growth. The sun radiation also affect the life of the drip system because the drip is system to component just like a laterals, mail lines, some mail lines, and emitters. They are also deteriorated with the times if the sun is directly falling on the surface of the emitters and laterals. It will disturb the life of the drip systems. If the systems, our system is can also damaged by the animals, rodents, and insects. Insects and rodents also thieves the or and animals also take the due to the their food fallen on the system. They can destroy the our systems. Rodents can chew insect and machines. We can this food component can damage our systems. Close growing crop is not generally we required. We recommended for the drip system for the system because some crops go just like a dhan and just like a paddy and it is required the water stagnation. If we provide the water in that case, there will be the water. There will be the it may be the cost of the high because pumping cost will be high. You have to maintain the more time. You have to operate the system for the more time. So it means there will the cost of energy will be high. So in that case, we not recommended that you use the drip systems. Require the high level of design and management. If this section is not covered, high level of design and management, then your system, your uniformity coefficient will be vary, and it may be possible that some plant get the higher water and some plant get lower water. For this system, we should have the carefully designed and management also. Initially, investment is high because it required the system, motors, pumps, and gravity head also we can use, but we have the also invest some money from that for this purchase the lateral main lines, sub main lines, filters, specification unit. Then it means it required a high initial cost, and it's required a skill level. If skill level not mm, present in the field, then it may be possible that your system is not operative according to that. In precision irrigation, we can get the answer of the four questions. Yes, sir. How much, when, where, and how. How much waters we can apply, we can do by the precision irrigation. When we have to give the our water to the plant at the which stage water plant require the water, more water, less water. We can manage by that this system also precision irrigation. And where we have to apply the water only to the root zone and root zone we can do by this method. Surface methods just like a border we can't get the questions answer of these questions. And how much and how this how which method we can use just like a sprinkler, just like a micro sprinkler, deepers, bubblers. We can use this method in the system. These are some application of the system. You can say these are the orchards of the shallow root zone and shallow plant root. We can using the dip system in this. You can see there. Some greenhouse also and polyhouse also. We can use only dip system. We will not use the surface method. We will use a deep system. Which you, if you are investing the too much money on polyhouse, and then it is also you use the optimum amount of water, and it is optimum amount of water you can do, monitor only by the drip system methods. Means we are using the drip system in the polyhouse. Terrace also, if you want to plant some horticulture crops on vegetable crops on your roof, then you will not use the surface method. You will use only drip system methods. Steep slopes, if your area some have the steep slopes, if you provide the surface water will run off, all the water will go to the down. But in the steep slopes, you can use the drip system method. Some residential gardens, kitchen gardens, we can use some shopping malls embankment, or we can use the drip system method. The water requirement, right amount of irrigation, it means how much. Then it depends on the soil of water molding or water holding capacity and percentage wetting area. These sections we can, these are the function which we want to the in the how much water of irrigations. This question, how much water we can calculate, there is some formulas just like a pan coefficient, or you can say the ETG is the pan operation coefficients, or there are very many different methods to calculate the ET0. And ET0 then multiply by the Kc factor. Kc is the crop coefficient factor. Then you can get the crop water requirement, the ETC in mm per day. This is some graph for the apple crops. They are showing that the value of Kc is the this one, Kc is crop factor. Kc is depend on the growth of the plant. Its initial stage, the Kc value is less when the time is passed, and initial stage 1 to 2, for 20 to 30 days, it is the less amount of Kc value, but it increase at the after development stage and mid stage. It's a 2 to 4. This is the here you can see there is a high amount of high value of crop coefficient, which will affect the crop of water requirement. It means at this stage the water requirement will be high. We can do the irrigation scheduling on the basis of AT. AT is calculated by the different method, and this can AT you can provide the how much demand to water is applied to the systems. There are some formula to water requirement. It is 0 into Kc and Kr. Kr is the reduction factor, and the reduction factor is calculated by the 5.0 plus Gc ground cover. And if you multiply Kr, Kc, and Gt0, then you can get the water requirement of the plant, and it means how much water is applied from the irrigation systems. There is a formula for the volume of water calculation. EP, Kp, Kp is the time coefficient, Kc is the crop coefficient, Sp is the spacing between the lateral, and Sp and Si is the crop spacing to row to row, and this is the plant to plant, and Wp is the wetting percentage of the area, and Ep is the pen coefficient. We can use the pen coefficient. We can use in this place on the a different empirical methods just like the radiation methods, Feynman methods, and different methods we can use for this. There are some calculation for the to calculate the crop water requirement and not. These are the some technical terms which we use in the irrigation. It's a saturation, field capacity, wilting point. At the saturation stage, all the pores of soils are filled with the water. There is no irrigation. But in the field capacity, some amount of water is drained to the gravitational flow, and remaining amount is in the soil is at the field capacity. It means the pores are partially filled with the air and the water. At these sections, when water is maintained at the field capacity, our plant growth will be maximum and yield growth will be maximum. And if we go to lesser this section, if the tension is increasing and increasing up to wilting point, and wilting point means the plant just start to die. If there are two terms, permanent wilting point, ultimate wilting point. Permanent wilting points means you can give the water to the plant. If you give the water to the plant, it can survive. But at the permanent wilting point, if you give the water to plant will not survive. It will be die. The permanent and the it means ultimate wilting point. At the permanent wilting point, the soil moisture tension is about 15 bars, and the as ultimate wilting point, the soil moisture tension is about 30 bars. It means in the drip system we maintain the water up to full capacity. You see the different curve. This look like it. This curve. This is a zigzag line is showing the lines water lines which are maintained by the drip system. This is the line indicate the sprinkle irrigation. It means the drip system maintain the water requirement, water and the soil at a full capacity. And the sprinkle irrigation, it means the water holding capacity up to 2 to 5% less. So it means when water goes to reduce the soil 25%, then we provide the water through the sprinkler. And in this method, the 50% of water have been reduced in the soil. At this stage, we provide the water through the surface irrigation methods. You see here, we only say dripping system methods or precise precision irrigation system maintain the water in the soil up to full capacity. It means you can get the high yield. Different methods we have to measure the soil moisture, just like the tensiometer we generally use. There are TDR also. But tensiometer is very cost-effective methods, and some other instruments like a PDR and they are highly something costly methods. So then we use the tensiometer. Tensiometer we put the tensiometer just like you see there. We are that the tensiometer. This is a tensiometer. We insert the soil tensiometer, and according to tensiometers, tensiometer tells about how much water is going to down. It means how much tension is in the soil. According to that tension, you can scheduling your irrigations. We use this some electronic devices as solid valve. They give the signal from the tensiometers, and according to that tensiometer, this valve is on and off. If water is going to down, then it was automatically on, and when water is going to up, then it was automatically off. That's lateral line or water. These are some tensiometers. We are provided tensiometer different depth. You see the plant up to the 100%, 25% depth of the plant root get the 40% of water. It means if up to here only 40% water is extracted by the plant. If we go down the 30%, next 25%, then 30% water is getting from the next 25% depth. If you more 35, 25% depth, then only 20% water is getting extracting from the soil. If you go 10 or 25% depth, only 10% of water is extracting by the root zone. According to 10, then we have the installed our tensiometers. This is the going to water requirement. Water requirement will be high at 12 o'clock and 3 o'clock in a day because at the time sunshine is on the surface, sunshine is the maximum. And it means over transmission is the maximum, transmission rate maximum, water loss is maximum. There are some electronic device which we use to automate our systems. These are the pumps, these are fertigations, these are the computer operated. We provide the these are electronic device. We give the signal to our systems, and according to that signals, our computer is operated to the systems. This is a micro sprinkler. Micro sprinkler, we are seeing the right place of the. It means we inserted the sprinkler at the near the root zone, and it provide the water to the root zone only. There are some example of the water pattern in the soil surface. Deep insert system is irrigated only a root zone. You are seeing the only irrigated, but the sprinkler irrigation little bit increase in the amount of water is spread beyond the root zone. And in the surface irrigation method, you can see there is a percolation also, just like at it. That's why we can get the lesser water efficiency in the surface irrigation method compared to diffusion methods. These are the waterfront. Waterfront are different in the different soil. If you see the sandy soil, then water will be go down, deep down, and waterfront will like this. If you go see the clay soil, then there will be some horizontal movement and vertical movement also. But if you see the clay soil, the vertical movement is very less compared to the horizontal movement. It means if you solve the sandy, more water will be go down. This is the some example of water distribution deep isolated. If the deep system is have the high discharge, then just like a section, more water will go down. If the low discharge, then it will be some lateral movement, and also you will get in the deep systems. Right manner of irrigation, we have the different methods. Well, how which method you can use? They are the subsurface method, sprinkler irrigation, micro sprinkler, bubbler, pop-up drip irrigation. These are system designed according to their water requirement. These are also the system also designed on the online basis, inline in the surface and subsurface. Let us slide. I will show you some pictures of the drip system. We will integrate the online emitters, inline surface and subsurface also. And so micro sprinkler, bubbler, these are some example of the micro irrigation devices. Micro jet drip system, bubbler, and micro sprinkler. These are this is a diagram of the our idle diagram. You can see it of a system in which we are using the pump to lift the water. There are some bypass valve because only suppose we use a 10-liter of water and it is pump water. Pump is lifting the 15-liter water, and we require only 10-liter water. It means 15-liter water, this pump is pumping, and we have to leave only 10-liter water. It means 5-liter water we have to stop. This water stop using the bypass valve. We can divert the 5-liter water to the well again. Only 10-liter water we flow. This is the NRV valve. NRV valve. NRV valve is a non-return valve. Only one way flow will be occurred. Water will go ahead. No water will come back to the pump line. And these are sand. These are the filters we use in the tip system. These are sand filters. These are the hydrocyclone filters, and this is the sand filters. This is the skin filters, and this is the some venturi. Venturi used for the fertigation purposes. These are the four filters. These are the one, two, three, and four filters we use for the drip system. We can eliminate any one filter, just like according to water quality. We can use. We can select these filters. If your water is clean, then you can use a skin filter. If your water is dirty and some sand particles there, then you can use the sand filter also. If there's a leaf, some high density particles is there in the water, then you can use the sand filters. Then these are the main lines. These are main lines. These are some main lines, and these are the flush valve. And this is the air release valve. We provide the air release valve in the main line, some main line also, because if they due to the movement of water, there is the chances to trap the some air, and this air bubbles decrease the velocity of the water. If you remove that this air bubbles from your main lines, then it will be helpful to maintain the proper pressure in the lines. If you not use this section, it means your water will be disturbed, your water distribution pattern will be disturbed. It means due to the it reduces the air purpose, it reduces the pressure in the water pressure, water better flow. It means water want to reach how much water is required, pressure is required here. It will not get to the air purpose which is introduced by the flow of the water. And there is some flush valve. Flush valve is also required to flush the lines, because if you will not flush the valve, if you will not flush the line, if you stop the line for the after irrigation for the 10 days or 5 days, there is chances to develop the algae growth in the main line of some main line. If you will not flush this algae growth, algae in the lines due to using the flush valve, there is chances the algae is going to the emitters, and it will chances to block this other emitter, because the emitter has a very small opening. So it means they are the using the flush valve to flush the valve. And these are the dippers. They are dippers. The only plant fruit zone are the wetting. They are providing water near the plant fruit zone only. There is surface method with irrigation. These are the you are seeing that the surface method or irrigation. There's subsurface below the surface. You have the install your dip tape, and this is the bubbler systems. Bubbler system, this water apply in the form of the fountains, but discharge is very less compared to sprinkler irrigation, and the water spreading distance is very less compared to the sprinkler irrigation. And the discharge of this is up about the 450 liter per hour. These are the micro sprinklers. For micro sprinkler distance is also very rare. These are the meters. Meters, they are the two types of meter. We use the online meters, online pressure compensating meter deepers. It means in the hilly areas, the chances when you lace your lateral lines and with the drip system, the chances to develop to the some pressures at the lower end of the drip system, drip line. If you will not use a pressure compensating deepers, then it will disturb your water uniformity pattern. This means at the lower end, water will be more get and compared to the high level of the systems. These are the some online non-pressure compensating keepers. In non-pressure compensating, discharge is the constant and pressure is a constant. There are some examples of the non-pressure compensating. They are the inline ammeters. These are the ammeters when company manufacture a lateral, they insert the ammeters inside the lateral at the time of manufacture. And you are saying here, they are the ammeters inside the lateral. This is a lateral, there is the ammeters. These are the inline ammeters. These are the bubblers. They are bubbler systems. Bubbler system is used also microwave system for the two, because it is deliver the high amount of water, then we can use for particular high water requirement crops. These are the micro sprinklers. Fertigation unit we have used in the fertigation unit because in a drip system there is the we apply the water in the in the near root zone, or we apply the fertigation in the near root zone. You have to compare with the surface drip systems and the surface irrigation and drip system methods. You can see that there is the apply the fertilizer and it's going to leaching. Okay, it's going to go down below the root zone. But in the drip system fertigation method, only only fertilizer applied near the root zone, and it is evenly spread, uniformly spread near the root zone, but it is not possible in the drip system, in the surface system. And just these are the some methods of fertigation. These are the methods of fertigation. Fertigation applied by the venturi systems and the fertilizer tank, just like a this is the pressure pumps, fertilizer pump. These are the example of the venturi. In the venturi, this section is inserted in the submerged of the bucket, which bucket has the nutrient, water soluble nutrient, such as urea, and it's due to the venturi flow, the water is stuck, and from here the clean water is coming, and water and due to the this section, it suck the fertilizer from the fertilizer tank, and it mixed with the irrigation water, and it go to the fertilizer tank. Look here, this is the pump, and this section you are seeing here. This is the venturi system. This is the venturi system which are going to either here. Calculation of injected, we can use this formula U into A into T, where Q is the quantity of chemical to be applied, A is the area, and T is the injection duration. I'm just telling about the so filters. Different types of filters we use in the system, just like a hydrocyclone filters. These are sand filter. This is a skin filter. This is a disc filter. These are the four filters we use in the electric system. You see the skin in the skin filter. You see the disc. There, disc is mounted in this in a bar, and they are pressed. And this has the some grooves from where clean water is come out. This is the hydrocyclone filters. These are the hydrocyclone filters. This is the chain filters. This is an example of filters. This is the showing the working of the hydrocyclone filters. Water is coming from the this side. There, from one section, water is coming, and it carries the centrifugal force and move just like this and go to down, and then lift to from the center. Clean water is from lift from center, and that particle which have the high density is collected at the bottom. And this is the clean by particular time, and that can be moved from here, just like this section is showing this here. This is the hydrocycle filter working showing there. Water is high density water is going to attach here, and it's going to slide, and it's collected at the bottom of the tank, and clean water is going to up, and it is going to your main line. Some sand filter example. These are some sand filter example. In the sand filter, there are some media we provided at the middle of the sand filter, and from here one section one clean water is come, and it's go to down, and there's a media. This media is trap the dirt particles, and from this section that particle trap by air, and clean water is going to down, and then this clean water is going to out from this section. This section going to out. It has shown that working the skin filter. You see the skin filter. There is the some clean dirt water is coming to section outside. This is the screen. Some clean dirt water is coming to this side. This side. This is the dirt water coming from this side and going to inside the clean water. And that particle is trapped by the skin. And this section is going to outlet. It is the inlet in the skin filter. This is some models of the skin filter. Now we will discuss about the maintenance of the drip irrigation system methods. There is the if we don't maintain our system properly, then it is chances to have to some lesser uniformity coefficients. And for this, we have to the structure we maintain. First is the filters we have to maintain. These are the filter we have to maintain. Then we have to maintain our emitters and some. You see the in the if you lay the if you install the drip system, and there chances is some animals work on the field and they disturb the strengthening straight portion of that lateral, and it may be disturb this section. Then you have to maintain this one also. Lateral lines. We are maintaining the emitters. Emitters just we open this. This is the emitter. These are the emitters. These are the emitter we open from the head of the emitters and clean this one emitters. These are the filter cleaning. In the filter cleaning, we see first one is the hydrocyclone, how we clean it. There is the that party is collected at the bottom of the chamber, and we remove this chamber, that particle by opening this section and clean this that particles. Sand filter, how will you operate it? Sand particle, there is some automatic system in the sand filter. There is some bypass assembly. There is a bypass valve. Water is coming from this. Is regular time is a normal condition. Water is coming from this section water will come and it go to down and clean here, and here the some media which trap that particle and clean water going to down this direction. But in the backwash system, we provide we just reverse the flow of the water. It means this gate valve we close and this gate valve we open. The water will come from this side and go to this side, and this is the media, and the water will go to upside, and the hide that particles it lose the here, and this water is really go to this section also. And that particle we go for to 5 to 10 minutes we backwash and our filter will be clean. Here is the some plates, they are the some candles, and here we fill the media. Media is the sand or more than sand size particles we put here. Here the media. We are the skin filter. We just open this section, and we just open this section and take the skin of the filters, and we wash this skin manually and then again put here. These are the skin filters. These are the filters. Similarly, this is here. We take out the disc from here and that's clean from the water and then again put here. This is the maintenance here. These are the some fertilizer equipment, but pressure tanks, venturi injector, and injector pump. These are the fertigation units we use in the drip system also. These are the some chemicals injector. These are pressure pumps. There are chemicals depend on the your dirty conditions or your. We can also use this pesticides and other chemicals using the distractions. Submain laterals, these are the submain laterals. Submain lateral flush using the flush valve. The length of the submain lateral diameter of submain is about more than 60 mm or 43 mm, 40 mm approximately. The diameter of this section is the 63 mm, and these are the made of the PVC or SDP, and these lateral are made of the linear low density polyethylene, and these lateral come in the size of these lateral come in the size of 10, 12, and 20 mm. This 16 mm. This come in the size. These are the meters. These are the meters are made from the propylene material, and these are the lateral is made with the black color, a linear low density polyethylene. We are making. Some chemical treatment we take, acid treatment we take because there is chances to flush algae growth we use it with reduce with the chlorine treatments, and some hardness which is deposited in the some precipitation deposited the latent line, we can remove this due to the with the using acid treatments. These are some slides of your for about the deep systems which I have shown you, and Hello, sir.
Thank you, sir, for your very informative lecture about precision agriculture. And there are a couple of questions from Dr. Asma Sherwani
Yes, yes,
for you.
yes.
Her first question is that how do weather forecasts and real-time data influence irrigation decision in precision system?
So at present, we are
Uh,
working. Yes, yes, yes. Yes, pardon, sir.
I repeat the question again.
Yes.
How do weather forecasts and real-time decision in the precision system? You can see the question for yourself in the chat box.
Mm-hmm.
It is in the chat box. Right third button in the bottom.
चीम हाई खाई ठीक है जी खाई के
Yes,
बाद क्या आएगा
yes, sir. How do we weather podcast and real-time data influencing? Sir, we have working on these questions, and we have. I am also a part of the co-PI of the PVTC project. We have contacted some company which we give the some software and